All right, welcome back to Mr. PL's with Precal. This is Unit 3, Topic 3, Lesson number 3. So we're going to do some verification. If you've watched the last couple of videos on simplifying identities, this should actually be a little bit easier because all you're really doing is using what we learned in the last two videos in order to do this. All right, so we're going to start with a warm-up, which just practices what we did before, which is practice using our identities. So cosecant of x, cosecant, as we can see down here, using a reciprocal identity, is really 1 over sine of x. Being multiplied by cotangent of x. Cotangent of x is the same thing as 1 over tangent of x. And, well, if I keep sine of x just sine of x, so sine of x over 1, and multiply tangent of x over 1, now you'll see that we have two pairs of reciprocals of each other. If we multiply 1 over, because we can use the commutative property of multiplication. We can really multiply in any order we want. If I multiply this times this, sine of x over sine of x is 1. So these basically cancel each other out. They become 1. And then 1 over tangent of x and tangent of x over 1, these are basically reciprocals of each other. So they also turn into 1. So the answer is 1. Because literally these two are reciprocals of each other, so are these. So if you multiply a reciprocal, I mean, that's what definition of reciprocal is. If you multiply any number by its reciprocal, it's always going to equal 1. All right, so now this question over here. So we are adding things, so we cannot do it unless we have the same base. So in order to get the same denominator. So in order to get the same denominator, I'm going to multiply top and bottom. It's basically rationals here, so I'm just going to multiply both sides by the other denominator. So I'm going to multiply this by 1 plus sine of x times 1 plus sine of x. Over here, I'm going to multiply this by, sorry. Man. I'm going to multiply by the other one, so that would be times 1 minus sine of x times 1 minus sine of x. And then multiply this side by 1 plus sine of x. 1 plus sine of x. Okay, so that's going to make the denominator 1 plus sine of x times 1 minus sine of x. All right, so then the numerators, since the denominators were the same, you could literally just add them together. 1 plus 1 makes 2, and sine of x plus negative sine of x makes nothing because those are opposites of each other, so they cancel each other out, plus and minus. Okay, so now I'm left with this. And then I look, 1 plus sine of x times 1 minus sine of x is the same thing as 1 minus sine squared x, because they're differences of squares, if I just multiply them by each other. And now I notice that on the bottom, 1 minus sine squared of x, so if I move this in the Pythagorean identity over to here, that'd be 1 minus sine squared of x, is really equal to cosine squared of x. So it's really 2 over cosine squared of x. And then the reciprocal of cosine squared of x, so 1 over. So if I separate this into times 1, 2 times 1, and use the 1 over cosine squared of x, then that's really the same thing as secant squared of x. So the answer is 2 times secant squared of x. And there you go, simplified as far as possible. All right, so we're going to introduce you to some more identities, and I'm not really going to get too much into this, but I will try to do my best to kind of explain where these come from. If you do understand that, then sometimes they just kind of make sense. It's not really about memorization, but once again, you will be provided all of these. So this is sine of negative x. If you think of negative x as going the wrong direction, so instead of going counterclockwise, if you're going clockwise around, now if you go, because x just represents the reference angle. So if the reference angle is right here, and I don't know what it is, let's say it's 45 degrees, and if I go negative x, I'm really going negative 45 degrees. Now if you think about it, that means you are by definition in the fourth quadrant. So anytime you go negative theta, or negative whatever the reference angle is, then you're in the fourth quadrant. Now, if you're in the fourth quadrant, so all of them are positive in the first quadrant, the only sine, only cosine, and only only cosine is, not sure why I'm not writing here, so only cosine is going to be positive in the fourth quadrant, which is the reason why, if you look at them, the reason why it's odd and even identities, the only two that are positive are cosine of x and secant of x, which are reciprocals of each other. So it makes sense that it's going to equal the same thing as the other thing. It's going to equal the same answer, but the opposite, because it's going to be negative in the fourth quadrant unless it's either cosine or secant. So that just kind of makes sense. because the nature of which one you're in. Now, this one over here, this is going to be a little bit trickier. So you probably learned back in like geometry that if you have a right angle and this is 20 degrees and this would have to be 50 degrees. And the reason I know this has to be 50 degrees is because, oh, it's 70 degrees. Oh my gosh. Basic math here. So if that was 20 degrees, then this would have to be 70 degrees. And the reason I know that is because 90 minus whatever this theta is, 90 minus 20 equals 70. So basically, when you have 90 degrees, because that's what pi over 2 is, minus theta, which will be whichever one of these angles is. So you probably learned back in geometry that sine of this angle is equal to cosine of the other angle. Well, that's really what you're doing here. So basically, you can see it now. So cotangent of the other angle is going to be the reciprocal of that same answer. So, like I said, sine of 90 minus theta, so sine of this angle is going to equal to cosine of the other angle. So that's basically why these identities make sense. I'm just trying to break that down. But once again, it's not about knowing and understanding the identity. It's about can you apply the identity. So that's what I'm going to do next. So cosine of pi over 2 minus theta, well, that's cosine of, that's this one right here. So that's basically just sine of theta. Over cosine of negative theta. If I go over here, cosine of negative theta is equal to cosine of theta. And sine of theta over cosine of theta, you should know, is just tangent of theta, because sine is y over x. So there's your answer, tangent of theta. Over here, cotangent of negative x will be negative cotangent of x, and that makes sense because tangent's always negative in the fourth quadrant. And if you've gone negative x degrees, well, then obviously you're negative. And then I'm going to change tangent of pi over 2 over minus x. So tangent of one angle is going to equal cotangent of the other angle. So let me find that. That'll be over here. Cotangent of x. All right, so now you've got cotangent of x divided by cotangent of x, which equals 1, and that's really negative 1 over 1, so the answer is negative 1. Okay, so verifying. So this is basically kind of the same thing as I've been doing with the last couple of videos. The only difference is we're given an equation now, not an expression. So we're trying to prove that this and this are equal to each other. Now the best way of doing it, and not the only way of doing it, is probably just to pick one of the sides that's easier and leave it alone and try to make the other side look like this side. So tangent of x, or of a, this is alpha actually, tangent of alpha times cosecant of alpha. So I'm going to keep using the same properties. So tangent is the same thing as sine of alpha over cosine of alpha. I know I'm not drawing it correctly. I'm not a big fan of using alpha, honestly. Cosecant of alpha. Cosecant is the same thing as 1 over sine of alpha. And then you'll notice that these two can be simplified so that you really have 1 over cosine of alpha equals secant of alpha. Now, 1 over cosine of alpha is secant of alpha. So basically, I've made the other side whatever, equals secant of alpha. So this has been verified. I've turned the left side into secant of alpha, which is what I wanted it to be. Okay, so 1 minus sine squared of b. So I'm going to leave that side alone because it looks a little bit simpler, and I'm going to try to make this turn into this. So 1 plus tangent squared of beta. So 1 minus tangent squared, that's 1 plus tangent squared is equal to secant squared. So this is basically 1 over secant squared of beta. Now secant squared of beta is the same thing as 1 over cosine. So if I use leave change, that's leave the 1 alone, multiplied by, well, 1 times anything is itself. So 1 times secant squared of beta is the same thing but flipped. Secant squared of beta is 1 over cosine of theta. So that becomes cosine of beta over 1, and 1 times anything. So this is basically just cosine of beta, all of this right-hand side. So cosine of beta, and I want to turn it into this, 1 minus sine squared. Well, the easiest way of doing this actually is kind of going against my logic from before. I realized my mistake when I just paused it just now. I forgot the squareds. I forgot when this was squared, then it stays squared, which means this stays squared. Okay, that was a very important thing because cosine squared of beta, if I use this trig identity right here, and I move this to 1 minus sine squared of theta, cosine squared of theta is equal to 1 minus sine squared of beta. So they're equal to each other. So I was just really missing that squared because... yeah, if this is squared, then this has to stay squared. It has to stay squared all the way through. All right, so some more advanced questions. All right, so we have this side being multiplied by this side. So I'm going to try to simplify them as much as I possibly can. So 1 plus cosine of x. 1 plus cosine of x is... oh, can't use my Pythagorean theorem. All right, so basically I'm not going to simplify this at all on the left-hand side. I will for this one. So I'm just going to multiply these as they are. So this is differences of squares here. So 1 times 1 is 1, and this is going to be negative cosine squared x. Not sure why my pen's not working. Okay, so over sine squared x. All right, just gonna have to deal. So 1 minus cosine squared of x, if we use our Pythagorean identity, 1 minus sine squared of x is cosine squared of x, or the other way around. So 1 minus cosine squared of x is sine squared of x. So this becomes sine squared of x over sine squared of x. Okay, my pen's not really working. Hopefully you're hearing me. Anything over itself is going to be equal to 1. I'm going to pause and try to fix my... all right, now I'm going to try my best on this one. I did do this question off screen. I hope I remember it. It was about 5 minutes ago about my strategy for doing it. So keep in mind that this is basically the same thing as over 1. I want these two to have the same... I want to turn the left side into the right side. First of all, let me get that out of the way. I'm going to multiply both of these by tangent of phi. So tangent of phi, and that's going to give me 1 over tangent of phi plus tangent of phi squared over tangent of phi. So now they have the same denominator, so they're both over tangent of phi, and 1 plus tangent squared of phi. Okay, so from here, 1 plus tangent of phi, 1 plus tangent of phi is the same thing as secant. So I use my Pythagorean theorem, the top turns into secant squared of phi over, now tangent tangent of phi, like that. So now I can change the bottom. And I can also I can split this up into 2. So this is really secant of phi times secant of phi. So that's kind of the trick here. Tangent of phi I can turn into sine of phi over cosine of phi. Because tangent really is y over x. So going from here, I'm going to leave that 1 alone. This secant right here is the same thing as, I feel like that was the trick. Secant is really 1 over cosine of phi. Okay, so that becomes secant of phi times 1 over cosine of phi over sine of phi over cosine of phi. Then I feel like what I can do is I can cross off the 2 that have the same denominators there. And that leaves me with just sine of phi, and the reciprocal of sine of phi is cosecant. So I still have my 1 secant of phi, and I change this sign by moving it to the top. I change it to this reciprocal, which is cosecant, the reciprocal of sine. So that's my way of verifying it, that it's exactly the same. All right, and I think that was my last one. Oh, there is one more. Oh, I'm not going to have time to do this one, so I'm going to actually stop right there. Thanks again for watching, and please look forward to future videos.